Welcome back for another training session in OpenDSS G. I'm Davis Montenegro and I'm the creator of the tool. Today I want to talk about a new feature that comes with OpenDSS G version 7, which is called the Topology Estimator. In the Constructor Tools palette nowadays you're going to notice that there is a new icon called Estimate Topology, which basically allows OpenDSS G to estimate what is the circuit topology based on its connectivity matrix and also with the lengths of the lines across the system. This is because many times when we create a new system, a new circuit, we don't want, or depending on the number of buses, it will be complicated to provide an adequate topology. So in this case, we are delegating that responsibility to OpenDSS G. For example, in this case, I'm opening the IEEE 13 bus node. I'm showing the buses and everything. It is evident that the distribution of some elements on buses is not necessarily accurate or matching the elements they are connected to. Buses, source bus and bus 650 are connected through a transformer. Same with the regulators. In this case, regulators should be represented basically as two buses very close to each other, because they normally correspond to a box or pole mounted installation where the input and output are very close to each other. Go to the icon that says Estimate Topology within the Tools palette, and you're going to get a little warning telling you that, well, explaining you what OpenDSS G is going to do, which is basically redistribute all the elements according to a topology estimation, and that if there is any heat map activated at the moment, it will be deactivated but can be reactivated later on. So here we have the circuit. I'm going to do a zoom all. And this is the distribution that OpenDSS G is giving us. To do this, OpenDSS G uses GraphViz and uses the connectivity matrix as well as the line lengths that are in the circuit. So here, for example, we can check that we have two lines and one is shorter than the other one. So when we localize them in the schematic, we can see that the new topology is considering those lengths for redistributing and proposing a topology that will be closer to what is probably on the field. Now let's do something similar with another IEEE circuit. In this case, we have the IEEE 34 node system. And as you can see, we have exactly the same problem that we were having before. Some of the transformers are not represented as they should. So we can infer that this distribution is more like an electrical schematic. We are going to bring the mini viewer here to display how things are looking with the mini viewer nowadays, which is a tool that we can use to help us navigate across the circuit model when zooming in and zooming out and, well, moving across the circuit. This mini viewer nowadays is resizable, which facilitates the localization of elements when we're moving very close to the schematic and we want to have a global perspective. Now let's apply the topology estimator, and this is the new topology that we're getting. As you can see, the mini viewer gets automatically updated, and every time we zoom in into an area, the mini viewer is going to show us where we are, considering the global perspective of the circuit. The same exercise can be geographical coordinates here, for which it is uncertain if these new coordinates that we are proposing will match with our geographical localization. However, it is good enough for proposing a new topology. However, it is important to clarify that the algorithm is not flawless. We have determined through several metrics and several measures that if the circuit has more than 800 buses, the algorithm may not work properly. So for that, with GraphViz, we have other algorithms that may be useful. They may not respect the line lengths, but can give a different topology that can be useful for other purposes. So when this happens, OpenDSS G is going to tell the user, hey, we have detected that your circuit has more than 800 buses. For that, pick one of the two algorithms that we are offering. We have the hierarchical, which users of OpenDSS G have seen before, and we have the SFDP algorithm. In both cases, you're going to get a representation that matches the connectivity matrix of the system, but not necessarily the line lengths. To finish this demo, I would like to show a concept that I mentioned before, and it was when a user is creating a new circuit model, how the topology estimator can help. So in this case, I'm using the scripting tool. I'm recreating the 4-bus system. This is the one that we're seeing on the screen right now, and as you can see, well, OpenDSS G has been placing elements randomly, as it does when We try to create a new element or new bus in the graphical environment using the scripting tool. So after using the topology estimation tool, the elements in the circuit are redistributed to provide a more accurate representation of the model, one that the user can further refine if needed. The key advantage is the time saved. Instead of manually repositioning each element to achieve a realistic schematic, the tool produces a layout that already reflects the circuit's electrical structure. I hope you found this training session helpful, and I look forward to seeing you in the next one. OpenDSS G has grown into a flagship platform for exploring and showcasing the full power of OpenDSS, and for more than a decade it has helped thousands of users learn, experiment, and innovate through an intuitive graphical experience. Each year we push the boundaries of what a graphical interface for OpenDSS can be, bringing the engine's advanced capabilities to life with richer visualization, smarter workflows, and tools that can accelerate both research and real-world engineering. To amplify that momentum, we've introduced the OpenDSS G roadmap, a dynamic community-driven space where users can vote for upcoming features, propose new ideas, and engage directly with the development team. It is designed to make your voice central to the evolution of the platform and to ensure OpenDSS G continues to meet the needs of utilities, researchers, consultants, and innovators across the industry. As an open source project, OpenDSS G thrives on collaboration. We invite users to share their perspectives, help shape priorities, and, if interested, join as contributors to advance the next generation of graphical tools for power flow simulation based on OpenDSS. Visit opendss.prodcom.com to start your journey helping to shape the future of OpenDSS and OpenDSS G. Thank you.